Hello, class, and today we are going to learn about work. Now, you guys probably are wondering what work is. Well, have no fear, I'm going to tell you what it is. Okay, so work is the product of the magnitude of the displacement times the component of the force parallel to the displacement. Work is a scalar quantity, so it only has magnitude and it can be positive or negative. Action.
Now, today we're gonna do a work example. So the example problem says a 15.6 kilogram block is dragged over a rough horizontal surface by a constant force of 185 newtons, acting at an angle of 33.4 degrees above the horizontal. The block is displaced 94.6 meters, and the coefficient of kinetic friction is mu equals 0.162. Find the work done by 185 Newton force. So here's the diagram that the problem gives, and the block, you see the block is here, is 15.6 kilograms, and force, the force is not acting straight horizontal, so it's not just being pulled, so you can't just use 185 degrees Newton, 185 Newton force. But it's being used at an angle of 33.4 degrees. And in order to find work, the formula for work is work equals force times displacement. So in the in the question, they give us the force, they give us the angle at which the force is being applied, and they also give us the frictional constant. So the force would be 185 newtons. The force of x is 185 newtons. The angle, the angle is 33.4 degrees. And they also give us the displacement, which is 94.6 meters. 94.6 meters. So in order to find work, you need to have force and displacement. So work is force times displacement. But since the force is acting at an angle, you would need to calculate the angle at which the force is being applied. So they already give us the angle, so we don't have to calculate the angle. But the force would equal, the force would be 185 newtons times cosine 33.4 degrees. And this is the force of x. Force of x. So in order to find work, you would take this and plug it into here with the displacement. So the total work would be 185 newtons times cosine 33.4 degrees times the displacement, which is 94.6 meters. Work is also in joules. And the answer is 14,610.7 joules of work.
So for part two of this problem, we're going to find the magnitude of the work done by the force of friction. So let U equal 0.162. So in order to find work, this is the force times displacement. And force equals kinetic N. So since force equals this, we can pretty much replace this for force. So whenever we rewrite it, over distance. Not over distance, but. And if we plug in all the numbers that were given to us in the previous part, it would be. No, let me rewrite it in the bottom instead, so it could be in the video. And if you multiply all this, your result would be negative 782.214 joules. And that would be the magnitude of the work done by the friction.
For part 3 of this problem, what is the sign of the work done by the frictional force? The sign will be negative because the frictional force is in the opposite direction that the block is moving. So for example, in the problem, the box was moving to the right, so the mu, the friction, is moving the opposite direction. So that's why the force will be negative.
Hey everyone, so I'm going to be working on part 4 of my group's project. So part 4 asks us to find the work done by the normal force. So work done by the normal force. So the equation for work done by the normal force is the normal force times the different distance traveled. So let's write that. Normal force times the distance traveled. So the normal force is in the x direction and the distance is in the y direction. So because the normal force is in the x direction, that's an x, and the distance is in the y direction, our work done is going to be 0 joules. If you have something going in opposite directions, there cannot be no work done.
For the last part, which is part 5, we will be finding the net work done on the block. And to find the net work, we're going to use this equation. And it's going to be the external force plus the frictional force, which looks like this. That's the equation. Now, from the previous parts, the external force is equal to 14,610.7 joules, and the frictional force is equal to negative 782.214 joules. Okay, you guys got it? Now we're going to add it together. So plus now using the book calculator, it's going to equal 13,828.5 joules. And there you have it, class. That is how you do work. Yay!